All right, we're going to start in Chapter 2 today. Welcome back. Chapter 2 is all about types of graphs, how to display your data, and what your data will look like in different texts. So first one we're going to do in Section 2.1 is frequency distributions. We're going to look at their graphs as well. You've probably done a frequency distribution before. Basically, it's made up of classes and then the frequency, how many times those numbers or how many times your data fits into that category. Each class has a lower class limit, which is going to be the least number that can belong in that class. And each one also has an upper class limit, which would be your largest. So in this example, 5 is your lower limit. 1 is your lower limit, 5 is your upper limit. 21 is your lower, 25 is your upper. The class width is the distance between the lower and upper levels of consecutive classes. The difference between the maximum and the minimum data entry is called the range. So some guidelines for constructing a frequency distribution. First, we need to decide on the number of classes. Usually your number of classes is between 5 and 20 so that you can detect any patterns. Any more than that will be harder to detect patterns. We're going to find the class width. We do that by determining the range, dividing the range by the number of classes, and we are always going to round up to the next convenient number. We want whole numbers here in this case. Find class limits. You can use the minimum data entry as your lower limit for the first class, and then you're just going to continue to count until you get to the upper limit for each one and the lower limit for the next one. Then you're going to make a tally mark for each one. Basically, tally marks look something like that. You've probably done them many times, and then you're going to count those tally marks up so that you can have the total frequency, or F. So our first example says, the data set below lists the out-of-pocket prescription medicine expenses for 30 U.S. adults in a recent year. Construct a frequency distribution that has 7 classes. So this time they gave us the number of classes, so we don't have to try to figure that out. They gave it to us. Since that's the case, then the next thing we're going to do is find the class width. In order to do that, that is the range divided by the number of classes. So we're going to find the range first. Range is your highest data point minus your lowest. So looking at our data, my range, the highest data point looks to be 405. The smallest data point looks to be 155. So 405 minus 155 is equal to 250. So to find the class width then, we're going to take the 250. We're going to divide it by 7 since it asks us for 7 classes. And 250 divided by 7, if you want to use your calculator, it's probably a good idea, is 35.7. So that means that we're going to round this up to 36. So that's going to be my class width. So we're going to go ahead and construct my chart. I'm going to need the class. I'm going to need a way to tally up the marks. And then I'm going to need the frequency. So we know that our class starts at 155. So where do we want to end? Well, we want we want 36 items to be in this class. So 155 plus 36 is going to give us 191. That'll be the lower limit for the next class. 191 plus 36 is going to be 227. And continuing adding 36 to each one, we would have 237 plus 36, which is going to give us 263. Plus 36 would give us 299. Plus 36 gives us 335. Plus 36 is going to give us 371. Those are all the lower limits. So now to find the upper limit, you're just going to do one less than this. So you don't want to hit 191, so one less would be 190. You don't want 227, one less would be 226. Then 262, and then 298, and then 334, and then 370, and last 406. And then you're just going to start tallying them up. So if we start going through each data point and start tallying them up. So 200 would fall into this group, 239 into the third class, 155 into the first, 252 into the next one, or the third one, 384 is going to jump all the way down to the last class, 165 would be in the first class, 296 is going to fall in the middle in the fourth class. And if we continue to do that one by one, we'll end up with 3, 2, 5 here, 6 here, 7 in the next group, 4 in the fifth group, sixth group, and then 3 in the last group. The only thing you have to be very careful of is to make sure you get all of your data points. And so when we tally these up or add these up, I am going to double check one more time and make sure that the sum, which is what this sigma looks like, this is the letter sigma, it's a capital letter sigma. It stands for sum, and so you're going to see this a lot. So if I sum my frequency, that means to take all of these and add them up. So 3 plus 2 is 5, plus 5 is 10, 16. 16 and another 10 is 26, plus 4 is 30. So yes, this did add up to 30, so we did hit all of our data points. We knew there were 30 to begin with, and that's what your frequency would look like. In addition to the frequency, we can also find some additional information about it. One would be the midpoint. The midpoint says to take the lower class limit and the upper class limit and divide by 2. So for the first class, we would take 190, subtract the 155, divide it by 2. So 190 minus 155 is 35. 35 divided by 2 then is going to end up being, oh, I'm sorry, we should be adding these two numbers. I'm sorry. 190 plus 155. And that's 345. And 345 divided by 2 is equal to 172.5. So that's midway between this first class. And we would have to do that for each one of them. Okay. Your relative frequency is another formula. It says we're going to take the class frequency and we're going to divide it by the sample size. So in this first example again, we had 3. We're going to take 3, that's my frequency, divided by the 30, which I knew that there were. 3 divided by 30 entries is 0.10. All right, that's your relative frequency. Your cumulative frequency says we're going to continue to add. We're going to let this thing accumulate. So we'll see how that looks on the next part. So this is just a bigger chart. There's my class. There's my frequency, which we already did. It's also going to ask us to find the midpoint, the relative frequency, and then the cumulative frequency. So this is the start of the chart. We're going to go ahead and finish it. The two that aren't on here are 335 to 370 with 4 frequency. We also had the category 371 to 406, and the frequency of that group was 3. And again, I'm just copying back from what was previously done. Okay. So, if you look, we did the first midpoint, the 155 plus the 190 divided by 2. 345 divided by 2 then was the 172.5. So we're going to do the same thing here. In this case, we would have 335 plus 370. We're going to divide it by 2 because you're trying to find the midpoint, so that's halfway between. And if we did that, we would get 352.5. The last one, midpoint, would be 371 plus 406 divided by 2, which is approximately 388.5. Your frequency then, remember frequency is to take, the relative frequency is to take the number that it occurred divided by your total, which was 30 in this case. So in this class width, we had 4. 4 divided by 30 is equal to approximately 0.13. This bottom one, we had 3 in the frequency, so a 3 divided by 30 is equal to 0.1. So let's talk just really quickly about the difference in these symbols. The 2 squiggly marks means approximately. The equal sign means exactly. So squiggly is approximate. So it's approximately equal to 0.13. That's what happens when you round and it doesn't round equal. All right, so now for the cumulative, it says that we're going to continue to add. So 3 from the first frequency plus the 2 in the next frequency gives me 5. 5 plus 5 in the next frequency gives me 10. 10 plus 6 is 16. 16 plus 7 is 23. 23 plus the 4 is 27. And 27 plus 3 in the last group is 30. And again, this makes sure that 30 was the number of data entries that we started with. Okay. All right, so that's data in chart form. Now it's going to say, what do you want to do with that? Well, a lot of times we want visuals. So the first visual that we talk about is a frequency histogram. So this is what a histogram looks like. You've all done these before in several courses, probably not just a math class, but it's a bar graph that represents the frequency distribution. The horizontal scale is quantitative and measures the data values. The horizontal measures your frequency. So this is going to be your data values. This is going to be how often they occur, your frequency. And make sure that your consecutive bars touch. That's what makes this a histogram and not something different, which we'll learn shortly. Right? Because consecutive bars on the histogram must touch, bars must align and end at class boundaries instead of class limits. So now we have to talk about class boundaries rather than the class limits. All right. So what we want to do is we want to make sure that the entire group is taken into account. So in order to do that, we're going to take our lower limit and we're going to subtract 0.5, and that's going to give us 154.5. Likewise, we're going to take the 190 from the first group, and we're going to add 0.5, and we're going to get 190.5. This guarantees that the data is in this group and not right there on it. It's a little different, but you'll see as we get through the rest of it. Okay. We also, if you continue noticing, so if we go through, that was the 155 and the 190. So then we're going to continue to subtract and add. So the next grouping would be 191, and we're going to subtract the 0.5, and that'll give us the 190.5, which matches right here, which is what we want. The upper limit on that class was 226, so we'll take 226 and we're going to add 0.5, and that'll give us 226.5. So when we get ready to actually construct this thing, you'll see what we're talking about, how they have to touch. So we need an X and a Y axis. Along the y-axis, this is going to be the frequency, so how often it occurs. Along the x-axis is going to be the expenses. All right, in this case, this is going to be in dollars. I also want to make sure that I put a title. So my title is going to be out-of-pocket expenses. Okay. It also tells us we want to make sure that we're not avoiding this to describe any patterns, because it's not just that we have to do these things, but the idea is to see the patterns that exist. All right. So if I look back at my frequency, my highest frequency was 7, my lowest frequency was 2. Highest frequency is 7, lowest frequency is 2. So on my chart, I want to make sure that I incorporate equal distance between all of the 2 to the 7. So try to keep them somewhat equal distance. I am going to do 1 hash mark for each frequency, starting at 1, ending at 8. And then along my y-axis, I'm going to put the expenses. Because we're not starting at 0, we put what's called a break in the graph. And we're going to start here at 154.5. And then we're going to bump up to 190.5. Bump up to the 226.5. Bump up to the next one, which would be 262.5. Bump up to the next one, which would be 298.5. Remembering we're just adding 0.5 to the end of either adding or subtracting the 0.5 to the end of the class. The next one would be 334.5, and then 370.5, and finally 406.5. All right. So you're going to start with your 154. You're going to end with half above the 406th. Then you're just going to mark where the frequency is. So in this first group, we had 3. In the second group, we had 2. So in the first group, we go up to 3. And we're going to draw your box. The next group had 2, so it'll be lower. The next group had 5. So we're going to go up here to 5. The next group had 6. So we'll go up one more to 6. Then to 7. So up one more to 7. Then it dropped down back to 4. And then finally down to 3. All right. Sometimes you'll see the numbers on top. So you might see 3, 2, 5, 6, 7, 4, 3. You don't have to put those on here. In this case, it's somewhat easy to tell where these numbers fall. If it's a really different amount, that's hard. So if you need to see 6.25, you may want to show that that actually represents 6.25 rather than 6. In this case, they're all whole numbers, so you wouldn't see that. But as we go through these, you'll see why we use different graphs to identify different items. All right. So make sure that we are labeling. There should be a name on your graph, a title of your graph. We have to have labels on the X and the Y axis. It also tells us to describe any patterns. Well, it looks like the most out-of-pocket expenses are probably in these middle 3 groups. So that could be a pattern. Most expenses fall between, and you can say if you don't even want to include the 226, we could say they fall between 262.5 and $334.5. Oftentimes when it says to describe patterns, the pattern you see may not be the same as the pattern someone else sees, and that's perfectly fine. You are just describing what you see. I would not have been upset if you said most expenses are between 298.5 and 334.5. You could also say the smallest expense was between 190 and 226.5. That describe is yours. There's no right or wrong, typically, as long as you're looking at the data and making a decision based on the data. So again, there's going to be some try these. All right, so here's your frequency distribution table. It tells us we're going to use 5 classes. Don't forget to include the class, the frequency, the midpoint, the relative frequency, the cumulative frequency, and then construct your histogram. So there's going to be a lot of stuff in your table, and then your histogram on the next page. All right. Sometimes it's better or different to have your information done using the relative frequency rather than the regular frequency. Now remember, relative frequency is going to be a number between 0 and 1. Relative frequency is a number between 0 and 1. So these are going to be much smaller numbers. And sometimes the relative frequency makes sense. And so as we do this next chart, it's going to look very similar to what we just did. We still have out-of-pocket expenses. This is going to be, again, still my frequency, but it is a relative frequency. Okay. This is still going to be expenses in dollars. Okay. Along my x-axis is still going to be the same data points that we used before. So there'll be a break in the graph, and we're going to start at the 154.5, 190.5, 226.5, 262.5, 298.5, 0.5, 334.5, 370.5, and lastly 406.5. So again, try to keep these as equal distance between them as you can. Don't need a ruler, just eyeballing it is fine. Okay. But you want to try to keep everything uniform. And then we're looking at relative frequency. So again, relative frequency starts here at 0. It's going to go up to 1 at the highest. So let's look back at what our relative frequencies were for this example. And our relative frequencies were 0.1, 0.07, 0.17, 0.2, 0.23, 0.13, and 0.1. So our relative frequencies, the smallest is 0, actually 0.07 when you're looking at it on here, but the largest is only 0.23. So when we make our Y scale here, we can start at 0, but we only have to go up to 0.25. That's as high as we have to go. So that means that I would have 0.5, 0.10, 0.15, 0.20, and then 0.25. So it's still a histogram, so my bars are still going to touch, only this time, using what we had from the last information, the first expense hit 0.1. The second one was, this is 0.05. The second one was 0.07, so between 0.05 and 0.10. The next one was 1.7, so it's going to be a little bit between 0.15 and 0.2. Oops, that's not a very straight line. Let's see if we do that a little better. There we go. The next one was 0.2, so it's going to go up to 0.2. The next one's going to go up to 0.23, so not quite to 0.25. Then we're going to drop down to 1.3, so 1.3 will be somewhere between 0.1 and 0.15. And last is back to 0.1. So this is where it might make sense to put the number on top. So the first one was at 0.1. The next one was at 0.07. Then we were at 0.17. Then we were at 0.2, 0.23, 0.13, and 0.1. Now it's easier for you to see what these numbers actually represent because, again, you're not going to have a ruler. You're not going to have this exact. So by putting those numbers up there, it lets people, whoever you're displaying this data to, see where your numbers are falling. Of course, you also have Excel that will do a lot of this kind of information too. So if you're ever going into any kind of statistics or any kind of graphing for a meeting, then it's best to use Excel or to use something where that graph actually looks professionally done rather than just by hand. And again, this is where your relative frequencies came from. This is where your relative frequencies came from. Okay. But if you look at the shape of this one, the shape of your regular frequency and the shape of your relative frequency, and the shape is very much the same. What's different is what's across the y-axis. That's really the only thing that's different on these. So it's very similar. Okay. All right, next one is a frequency polygon. That is a line graph that emphasizes the continuous change in frequencies. So you can see where it continuously changes. So again, if we're going to do that on ours, using our data, across this, again, would be our frequency. So we're going to go back to the 0 to 8. 1, 2, 3, 4, 5, 6, 7, 8. Across here is going to be, again, the broken 154.5, 190.5, 226.5, 262.5, 298.5, 334.5, 370.5, 406.5, and we're actually going to have a last value here, and this last value is going to be 442.5, which just adds the additional 36 that we had before. Remember, our class width was 36, so I'm going to add 36 there, and I'll show you why when we get to the end of the graph. All right. So at 154.5, we are at, the frequency is, go back to my data. So at the 154.5, we're at 3. The 190, we're at 2. At the 226, we are at, oh, actually, we're going to start it differently so that it'll end up being where you need it to be. Sorry about that. All right, we're going to start at the 154.5 at 0 because we don't have really any technically in that group. But at the end of that category, we're sitting at 3. So at the end of this frequency, we're at 3. At the end of this class, for the next one, we're at 2. You have to remember where we're at the end of. At the end of the 262 class, we're back up to 5. Then we're up to 6 at the end of the next class. Then we are up to 7 at the next class, the end of the next class. We're going to the end of each class. Then we're back down to 4 at the end of the next class. Then we're back down to 3 at the end of the next group. And this is why we have this last category, because then at the end of that next category, we're back down at 0. So it's going to look something like this when we connect the dots. So now when we talk about patterns, we can say that perhaps this number here is a little bit unusual. It took a dip there. Why did it take a dip? Well, we may not know the answer to that, but we can certainly say in our patterns that the out-of-pocket expenses dipped at $226.5. We could also say the highest point or highest frequency was at the 334.5 mark. We can also say that after 335, people started decreasing. So it's about an increase and a decrease. Again, these patterns are yours to tell me. It's not really right or wrong as long as what you're saying does match the data. And then the last thing that we need to put on here, of course, is our title, which is out-of-pocket expenses. Okay. I will take off if you don't list your y-axis, your x-axis, and your title of your graph. This was also expenses in dollars. So get in the habit of actually labeling what your axes are as well as your title. All right. A cumulative frequency graph is also called an ogive. And again, it's going to just be the frequency of all of them. So one more time, let's look at our data. This time it's not just your frequency, but this time we're looking at the cumulative frequency. Along the x-axis, we are still looking at, let me move that down a little bit, expenses in dollars. The above graph is still, or the title of the graph is still out-of-pocket expenses. We still have our data points. There's still a break in the graph. So 154.5, 190.5, 226.5, 262.5, 298.5, 334.5, 370.5, and 406.5. Our cumulative frequency, again, if you go all the way back to the data that we first talked about, the cumulative frequency, that's going to be this group of numbers. So the lowest is 3, the highest is 30, because we're going to go all the way up to 30. So along my graph, along the y-axis, I want to go up to 30, so I'm going to start with 5, 10, 15, 20, 25, 30. And again, similar to the way we started the frequency polygon above, we're going to start out at 154.5 is at 0. At the 190, we are at 3. At the 226, we are at 5. At the 262, we're at 10. At the 298, we are at 16. At the 334, we are at 23. At the 370 mark, we're at 27. And finally, at the 406, we're at 30. So it sort of starts flat, then it starts increasing until we get to the top. That may be the least exciting graph that we've done so far, but it certainly shows a different way to look at the expenses. Maybe it doesn't give you as much information as you would like, but it certainly does show some. All right, so you're going to try the next one. You're going to do a relative frequency histogram, a frequency polygon, and an ogive, all dependent upon your data that you found in the first try it. So the data is the amount of time spent watching YouTube videos. Oops. All right, and then as soon as you get that done, we can turn that in along with the rest of the chapter notes. And that'll wrap up today's